All right, so you try to make the bases match. Can I make 4 and 3 match? No, not in any sort of easy, simple way. So we have to have a different approach when your equation looks like this. We're going to go ahead and take, you can do the log or the natural log of each side. I tend to do natural log just because it's fewer things to write. It's 2 letters instead of 3. I'm going to take the natural log of this 4 to the x plus 2 and the natural log of 3 to the 2 minus x. Now, you could do like log base 3 or log base 4, and it'd be a slightly different approach. I just like using natural log. Okay, when you have a log, where do these exponents, or where can the exponents go? Where? Yeah, in front. They become the coefficients, right? So I really have x plus 2 times the natural log of 4 equals 2 minus x times the natural log of 3. Okay, and then we can just distribute. So I'm taking natural log of 4 times the x and times the 2. So this is really x natural log of 4 plus 2 natural log of 4. And then on the other side, you'd have 2 natural log of 3 minus x natural log of 3. Okay, just distributing there. Okay, this is where you have to remind yourself what you're actually solving for. We're solving for x. So I want to make sure I have everything that has an x in it on one side and everything that doesn't have an x in it on the other side. So I'm going to leave the x natural log of 4 here. But I'm going to bring over the minus x natural log of 3, so I'm going to add it to both sides. So plus x natural log of 3. And then equals, I can leave my 2 natural log of 3 there and move over the 2 natural log of 4, so minus 2 natural log of 4. Let me stop there for a minute and make sure you guys see I just moved things around. I didn't do anything crazy. Anybody questions to that point? Okay, what can I factor out on the left? X, okay. Sometimes people will say, oh, factor out an ln. You can't do that, guys. Natural log is not, it's not a variable, it's not a value, it's an operator. That'd be like, oh, factor out the addition. Like, that's not something you would do, okay? So we can factor out an x, and I'd have natural log of 4 plus natural log of 3. And then right side we'd leave alone. So your answer of what x equals, what do you think I need to do to get x by itself? Divide. So I've got 2 natural log of 3 minus 2 natural log of 4 divided by natural log of 4 plus natural log of 3. Now that is a perfectly acceptable answer. There are other ways you could write this, though. I could use some of my properties here, and the numerator could actually be the natural log of 9 over 16 divided by the natural log of 12. Do you guys see it? Yeah? It's just using your exponentials here. This is really the natural log of 3 squared divided by 4 squared. Okay. Same thing down here, 4 times 3. So just be aware that if it's a multiple choice question, you might have to recognize your answer in a different format. Okay, but those are equivalent. They mean the same thing. Okay. Stab me if you have questions or you need to go back through anything. All right, guys, number 2. What's up? Question? Sure? Okay. All right, let's do log of x plus the log of x minus 3 equals the log of 28. All right, guys. So again, different setup. You can see how question 2 looks totally different from question 1, right? With logs, there are so many different ways that the question can be presented. You have to be able to look at it and go, oh, okay, I should try this approach on this problem. What we're going to do here is use some of our properties and condense this. So on the left side, if I want this to become a single log, what would you do? Log of what? Yeah, she said x squared minus 3x. Yes, you're absolutely doing, and we could even write it separately first if you want. You're multiplying the two, right? That's our property. This is why we have to learn the properties before we can do the solving, okay? And then on the right side, it just equals log of 28. Okay, similar to when we did solving the exponent equations, if you had the same base, you could set the exponents equal. Here, if I have the same single log, it's got to be just one log on both sides. I can set this x times x minus 3 equal to the 28. Okay, and now it's just algebra. So on the left, that would be x squared minus 3x. And then I'm going to go ahead and bring the 28 over. So minus 28 equals 0. How do we solve that? Factor. Yeah, what does it factor into?
It's equal to 7 and negative 4.
Okay, so we'll factor first. X minus 7 and x plus 4. And then what does x equal? You are absolutely right. It equals 7 and negative 4. Okay. When you're solving logs, you always have to check that your solutions actually work. So you guys remember graphing logs, hopefully. It was not that long ago. The graph looked something like that, and we had a vertical asymptote at 0. What was the domain of like the basic log graph? It's a Monday, guys. We can do it. Think about domain. So starting from the left, are there any values of the graph over here? No, it starts just after the asymptote, right? So we wouldn't include 0, but we'd go a parenthesis on 0 to infinity. Okay, that's because you can't take the log of a negative number. So when we're solving, we need to double check. Just because x is negative doesn't mean it won't work, but you just have to go up to the original and plug it in. So if I plug 7 in, Positive, positive, obviously positive. -4 though, is that going to work right there? No, so we have to throw out that answer. It's an extraneous solution. So the only one that works is is 7. So cross this guy out. There is your only answer for that log equation. And again, it's not just because the 4 was negative, it's because plugging it in created the log of a negative value. Okay? Pause for a second. All right, questions so far? Yeah. So what about that? Like, if I plugged it in here, it would be okay, is what you're saying?
I don't want the original problem. Change that plus X.
Oh, there is no property then. You're actually just dealing with a log times another log, and it's not a property. So just like we could only expand if it was multiplication or division, you can only condense addition and subtraction. Okay, so that's how this works. And then I know this isn't what you were asking, but when you plug in the value, make sure you don't plug it into the condensed version. Always go to the original when you're looking at it. Okay? If you plug it in there, it actually works. So don't do that. All right, let's try another one. It's going to look different again. All right, we've got the natural log of x, the whole thing squared, plus natural log of x, minus 12 equals 0. Okay, don't be scared by this one. This is just a trinomial. If I gave you x squared plus x minus 12 equals 0, could you solve that? Yeah, what would you do? What does it factor into? Good. So this original one, it's the same idea, but instead of just x's, we have natural log of x. Okay, so what do you think this one is going to factor into? You knew it when I wrote it in green. It's the exact same idea, guys. What's it going to be?
Natural log of x plus 4.
Yes.
Natural log of x minus 3.
Exactly. That's it. You're just factoring. Reminder, guys, keep those phones away from me. All right, from there, we still have to solve, okay? So I am setting natural log of x plus 4 equal to 0, and natural log of x minus 3 equal to 0. So the first one is saying the natural log of x equals -4. Okay, now we're back to what we were doing last week. Can you write that in exponential form? What's the base, because it's natural log? E, good. Remember, natural log is always base E. What's the exponent? -4, and it will equal x. Okay, there's one of your answers. All right, and then we'll solve the other one. So this would be natural log of x equals 3. So what's your answer for this one? Okay, there you go. You have two answers. Because, guys, e to the -4th, is that a negative number? No, it just means 1 over e to the 4th. Okay? So both of those, totally fine to use. Questions on that one? You guys see what I mean? How it's so many different ways that you might have to go about solving. You have to be very comfortable with all of the different rules. You have to be okay with your exponent rules, dealing with logs, natural logs, and e, factoring, all of it, okay? So, properties, I left that out. Takes a little time. We'll try again. All right, let's do e to the 2x minus e to the x minus 6 equals 0. So guys, when you look at it, do you go, oh, that looks like a trinomial, I should probably try to factor it? Is that where your brain goes? Or do you just go, oh, that's a lot of e's and I'm kind of scared? Is that where we are? Okay. So think of it as a trinomial. I'm going to go over to the side here. What if I said x squared minus x minus 6 equals 0? That's a lot less scary, right? It's essentially the same problem. What would that factor into? X minus 3, x plus 2. Okay. The key is you have to figure out what is x in this problem. So x is my middle term, right? E to the x is my middle term over here. So what do you think this is going to factor into? Any thoughts? It's going to be something minus 3 and something plus 2.
Natural log of x.
Not natural log yet. We will need natural log to solve. But just straight factoring from that blue part. What times itself is e to the 2x? E to the x, yeah. This middle term gives you a clue as to what it is that we are using in our factoring. Yeah.
Wait, how is it like factorable if it's 2x not x squared?
So if I were to multiply that out, e to the x times e to the x, right? What is that? E to the what?
2x.
Okay. Yep. It all comes back to really knowing your exponent rules. Okay. So then we've got to solve. Factoring step 1, we still have to actually solve. So I've got e to the x minus 3 equals 0. And I've got e to the x plus 2 equals 0. Okay, so the first one is really e to the x equals 3. Now, to solve that, there's a couple of approaches you can take. If you just recognize it and go, oh, I can write that as a natural log, great. Just rewrite it in natural log form instead of exponential. If you're like, I don't really remember what goes where, that's fine. Take the natural log of both sides. Okay, we'll practice that skill again. So I now have natural log of e to the x equals natural log of 3. That doesn't really look like a 3 anymore. Okay, with that natural log of e to the x, where does the x actually go? In front, right? That's the exponent. Yeah, what is natural log of e? 1. Great. So you could even skip that step and go right to x equals natural log of 3. So there's one of your answers. Okay, and then we'll try the other one. So e to the x equals negative 2. So again, multiple things you could do here. We can go ahead and take the natural log of both sides. Can I take the natural log of negative 2? No. The other way to think about it, guys, is there any way I can take e and raise it to some exponent and get a negative answer? No, it doesn't work, okay? So this does not give you any solution. So your only answer is natural log of 3. All right, one more in the notes, and I'll have you practice it. Let's do log base 3 of n squared minus 5 raised to the 4th equals 4. Second to copy that down. Okay, guys. So this one, again, it looks different, right? We have one log on one side and we have just a constant on the other side. Could I rewrite this as an exponential function? Okay, I'm asking because yes, you can. What would it be as an exponential function?
3 to the 4
Yep.
equals n squared minus 5.
Yes. And now this is one approach that we could do. Let me show you another one. What could we have done with that 4 right away? Yeah, let's look at that way, because I think it'll make a little more sense. They both work, but it's just another way to look at it. So then before I write it as an exponential, what could I do with the 4? Yeah, you can divide both sides by 4. So now you have log base 3 of n squared minus 5 equals 1. To me, that's simpler to work through. The other side would work. You'd be doing some fourth roots and things, you know.
Then you just take like the 4th root of both sides.
Yep, and then you have to make sure you're aware of your plus or minus and things going on. Yeah, there's a little more room for error on that side. So this one I could just write as 3 to the 1st equals n squared minus 5. And then how do I solve? Plus 5, so we'd be at 8 equals n squared. Still have your plus or minus to deal with here. How do I solve that? And what does root 8 simplify to? Okay, good. Okay, and then we have to think about it. Do both the positive and the negative work in this situation? Yeah, they do, because you're squaring it right away, so you're going to get positive 8 substituted in there both ways, and then you're good, because 8 minus 5 is positive 3. So you get those two answers. And again, over here, you could have done 4th root right away, you know, get to the same spot. Okay, questions on the notes? All right, let's practice a few more here just to make sure you guys are doing okay. And then we've got plenty of time. I'll give you time to work on your math space also. So somewhere just find somewhere to jot down a few more problems. Yeah, go ahead. Let me find what I want to give you guys. So hold on. All right, I'll give you a couple to start with. Let's do log base 3 of x plus 4 minus log base 3 of x equals 2. Natural log of x squared minus 13 natural log of x plus 42. All right, so go ahead and try and solve those two. And then we'll do some more. No? Okay, which one? Okay, so I like
Almost got it.
Almost got it. You were right there. I mean, it's algebra. That's not right. The simple algebra. The simple division. Yeah. One lack.
I hear about you.
Hey, I actually
Thought all the way to the end and you need 8x or x equals 2. I'm like, that's not right. That's not right there. Yeah. Yeah.
so I technically was right.
basic math.
So the first one is just condensing and breaking into the three and then
Oh, so the first way I thought of it, this yeah.
That's the other thing that's weird. Is that
Oh, well.
All right, guys, let's go through these two, and then I'll give you a couple more. We'll just keep doing a couple at a time. Okay, the first one, I see that subtraction sign in between, so that tells me I should condense this down with division. So this is really log base 3 of x plus 4 over x equals 2. Okay? And then you can rewrite that as an exponential. So 3 squared equals x plus 4 over x. Now you're back to just algebra land. 3 squared is 9, and I would be multiplying both sides by x to solve this. So 9x equals x plus 4. Means 8x equals 4. So when you divide by 8, you get 1/2. And 1/2 looks like it would work in the logs. There you go. All right, thumbs up on one, sideways, down. How we doing? Sideways is okay, guys. I understand. I mean, down is okay if that's where you are. Like, we'll keep working on it. All right, we're getting there. Okay, number 2, totally different again. This is a factoring problem. When you see 3 terms like that, hopefully it kind of goes, okay, trinomial, I should factor it. So this is going to be natural log of x minus 7 times natural log of x minus 6. Okay? And then I'm just setting each one of these factors equal to 0. And then rewriting it as an exponential, I get e to the 7th and e to the 6th. Those should both be fine. They are both positive values. When I plug them in, they look good. questions? Got them so far? If you got stuck doing it on your own, is it at least making sense when I'm going through it? Yeah, okay. All right, let's try a few more. Let's do 2 log base 5 of x equals 3 log base 5 of 4. And what else do I want to do? 3 to the 1 minus 2x equals 4 to the x. All right, let's try those two. Again, totally different. Check in with each other. How we doing?
That's 2x. X.
Art stuff.
So we're gonna go
Okay.
Oh my god. I'm just challenged here. I was like, you can't do that with X. It's so special. Well, I did that for that, but I was like, well, you can't do that because I'm going to get, you know, X. So that's how they yeah, this is
And you both, like, good job remembering plus or minus.
I just put it here, but it's not.
Yeah, you gotta look at the variations. Yep.
That's exactly 5x.
All right, let's go through these two. Okay, on number 3 up here. I see that I have a log base 5 on both sides, but I also have these coefficients, so I need to deal with those exponents first. So this is really log base 5 of x squared, and this is log base 5 of 4 to the third. Okay, we can rewrite it with those exponents. Now I've got it as like a simplified log base 5 on both sides, so I can just set x squared equal to 4 cubed. And guys, what is 4 cubed? 64. Yeah. Okay. And then I can take the square root from there. And so you get plus or minus 8. Do I want both the positive and the negative 8? No. If you look at the very first step, I'd be taking log base 5 of negative 8. I don't want to do that. So it's actually just 8. Okay? Questions on that one? Yeah.
So why can't it be negative 8? That would be 11. 5x. Wouldn't that be the same thing? X squared.
That's why I'm saying always plug it into the first step, not the second step. Because if you look at it, you'd be doing log base 5 of negative 8, and then times 2. And then, I know, it's weird. So always look at the very first original, what did we have? We just want the 8. Okay? Other questions on the third one? Okay, number 4, this is one of those where you cannot make the bases match and you have to do the log or the natural log of both sides. The exponent then comes in front. Then I can distribute, so this is natural log of 3 minus 2, sorry, there's an x. 2x natural log of 3, and I still have x natural log of 4 on the right. This time I'm going to go ahead and just move my x's to the right side. So I've got x natural log of 4 plus 2x natural log of 3. Are you guys with me to that point?
Yes.
Algebraically?
Just enough.
And then you're like, now I don't know what's happening. Okay, but we're good with that stuff. All right. This is where you go, what am I solving for? X, okay. Could I factor an x out on the right side? Okay. So I'm left with natural log of 4 plus 2 natural log of 3. That just blow your mind a little bit.
Alright.
Then what do I have to do from there? Divide. Yeah, so your answer is natural log of 3 over natural log of 4 plus 2 natural log of 3. Or if you felt like getting fancy, natural log of 3 over natural log of 36. But you don't have to write it that way. This way's fine. That's just properties. Okay. All right, questions? Sure. Okay. All right. Let me give you some time to work on math space here. Some of you have some second attempts you still need to get to. I will work on getting SIS updated for those of you that have done your second attempts. I know the test is still, like, it's not till a week from Friday, but I don't see you very many more times before then. This test, if you don't know it well, like if you look at number 4 and you're like, gosh, and you spend 5 minutes trying to just figure out the approach, you will run out of time on your test, okay? So it's a test where you have to know it well. So the math space part of the test, if you've done your homeworks, like you guys saw from the first test, it's very similar questions. Sometimes the exact same question from your homework. So do the homeworks, be as prepared as you possibly can be going into the test so that you aren't like, oh, what does math space want, and running out of time because of things like that. Okay. Again, you'll have an hour for the test. Those of you with extended time know who you are. You have an hour and a half. But just be aware. Not beware, be aware. Okay. Know your stuff. Know your exponent rules. All that good stuff. And 2.7, it's in there for you, right? It's showing up. Maybe make sure I made it open.